Good morning. Let's go ahead and look at Unit 18. This is a unit on probability. And so topic 18.1 is talking about theoretical probability, the probability in theory. So first of all, probability is the measure of how likely an event is to occur, how reasonable it is, how much chance you think there is that this is going to occur. The set of all possible outcomes is called the sample space. A lot of times the sample space is given a capital letter S, and we'll put the actual events in brackets like this. So for example, the sample space when I roll a die is this. The sample space when I flip a coin is this. So it's a list of all the possible outcomes that could happen in that particular scenario. For equally likely outcomes, the theoretical probability of an event, which is written P parentheses E, this means the probability of event E, is it's going to be found by adding up how many favorable outcomes there are and making a ratio to the total number of outcomes. So it's the ratio of the number of favorable outcomes to the number of possible outcomes. So in other words, if I'm rolling a die and I'm looking for a 1, the probability that I get a 1 is 1 out of 6. There's one favorable outcome out of the 6 possible outcomes. On the other hand, the probability that I roll an odd number is there's 3 favorable outcomes out of the 6 possible, which of course reduces to 1/2. So that's the way you'll write probabilities and their percentages or their likelihood of occurring. So let's look at a couple of simple events. A jar contains 32 red marbles and 28 blue marbles. What's the probability that a randomly selected marble is red? And this idea of randomly selected is really important. It'll be consistent with what we do because, of course, if I look in the jar of marbles, it's going to be pretty easy to pick out a red one. So we want it to be random, just like rolling a die or flipping a coin. So what's the probability I get a red marble? Well, it's the number of red marbles over the total number of marbles. So there are, of course, 32 red marbles, and totally we see 32 plus 28 marbles in the jar. So this is 32 over, and we're going to want to reduce this. So it's probably helpful for you to have a calculator. And so in this case, I've got 32 plus 28. That's what's on the bottom, 60. And so if I reduce it, I've got 32. Whoop. I don't want to do it there. Over here, 32 divided by 60. And remember, we press math and then enter to turn it into a fraction. And we get 8/15. Of course, if you needed it as a decimal, there's the decimal right there, 0.53 repeating. Let's look at number 2. The probability of a boy being picked to win a prize is 7/20. What's the probability a boy is not picked to win a prize? So the probability he's picked is 7/20. So what's the probability he's not picked? And this uses a couple of important ideas. First of all, the total probabilities add to 1. So if I look at each individual thing in the sample space, they add up to 1. So the probability he's picked is 7/20. The probability he's not picked is going to be 1 minus the 7/20ths. 1 minus the likelihood he is picked. This is called a complement. And the complement is the probability that it's not whatever it said. So this is going to end up being 13/20ths for the probability he's not picked. For example, again, if the probability of a 1 was 1/6, the probability it's not a 1 is going to be 5/6, the rest of the numbers. So let's look at number 3. A month of the year is randomly selected. What's the probability of getting a month that begins with the letter A? So the probability of an A month is going to be the number of A months over the total number of months. Okay, well, of course, there's 12 months in a year. How many of them begin with the letter A? January, February, March, April, May, June, July, August, September, October, November, December. 2 of the months begin with the letter A, and that will reduce to 1/6. Or again, if you want to use your calculator, I've got 2 divided by 12. Math frac turns it into 1/6. So what's the probability of getting a month that does not begin with the letter A? So it's the probability it's not an A month, which could actually be solved 2 different ways. I could go through and say, well, how many not A months do I have over the total number of months? So let's see how to do that. So I'm going to keep little tally marks. January, February, March, not April, May, June, July, not August, September, October, November, December. That's 10 out of 12, which reduces to 5/6. Or I can use the fact that this is a complement and work it this way. The probability it's not an A month is 1 minus the probability it is an A month. Well, we found that on number 3. So the probability it was an A month is 1/6. 1 minus 1/6 is 5/6. Of course, those equal each other because that's just 2 different ways to do the same problem. Number 5. A spinner has 12 evenly spaced sections. There's 4 oranges, 5 reds, 1 purple, and 2 yellows. You can check real quick. 4 plus 5 is 9, 10, 11, 12. That's 12 spaces. They're evenly spaced, so each space is going to be equally likely. What's the probability I get an orange space? So the probability of orange is the number of orange spaces over the total number of spaces. So there's 12 spaces, 4 are orange, and of course you could reduce that if you wanted to on your calculator, or perhaps the old-fashioned way, and we get that this is 1/3. What this means is for every 3 times you spin the spinner, you expect one of those to be orange. For every 3 times you spin the spinner, you expect one of them to be an orange. In a standard deck of cards, what's the probability of drawing a black card? So maybe you know this. There's 52 cards in a deck, a couple of notes. In fact, here's a table that shows all the cards that we have in a deck. There's 52 of them. It's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 4 times 13, that's 52. And you can see that there's some that are black and some that are red. So what we've got here in this question is it asks me, what's the probability of drawing a black card? So I could look here and count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So what we have is the probability. It's a black card is 26 out of the 52. And that reduces down to 1/2. Another way you might notice it is that we have what we call 4 different suits. These are 4 suits. This is the clubs, these are spades, these are hearts, and these are diamonds. So I have 4 different suits, and you see that 2 of those 4 suits are black. So you could also have done it like this. The probability it's a black card is the number of black suits over the number of suits total. Well, there's 2 black suits out of 4 total suits. Of course, those reduce down to the same thing. And finally, this question says, what's the probability I draw the ace of spades? So when I look back at this deck, this card right here is called the ace of spades. It's got an A on it. That means ace. And this symbol is the spade. A quick look shows there's only one of these cards in the deck. So the probability it's the ace of spades is the number of ace of spades over the total number of cards. So there's one ace of spades out of the 52 cards, and that's the probability of drawing it. This means, on average, every 52 times you draw a card out of a deck, one of those times will be the ace of spades. This means, on average, every 2 times you draw a card out of a deck, one of them is black. And that's a brief introduction to probability. Good luck and great effort.